Hi, my name is Robert Feranek. I'm from Fedevel Academy, and in this video, we are going to keep improving the layout of this board. Last time we improved a lot around vias, and in this video, we are going to improve the tracks. In this video, I'm going to use same board, but we will have a look at the layout from different times, from different revisions. And the layout was done by a junior hardware design engineer, so I will point out the areas on the board which I believe can be improved, and I will explain why we would like to improve them, and also we will have a look how the improved layout should be done. I really hope you will find this video useful, and let's do it. First, we are going to have a look at memory layout. This is what I have received from the junior hardware design engineer. This is the preliminary DDR4 memory layout between processor and the memory chip. And this is not like really maybe what we would like to do when we are doing preliminary layout. What do you think? Why? What we would like to improve here? Especially for memory interface, you really would like to keep a lot of space between tracks. Okay, this is what we can see here. This is not enough space. There can be crosstalk, and memory interface is like really important. You don't want your board to keep freezing or crashing. So you really would like to keep a lot of space between the tracks. After this layout was improved, this is how it looks. Okay, this is still just a draft. Don't forget, this board, it has not been finished yet. So this is just a draft, but even in this draft you can see a lot of space between the tracks. And also you can see he included these waves for length matching, because when you are doing draft or preliminary layout of memory interface, you would like to see how much space you will need to route this interface properly. So even this length matching is not perfect at this moment. These signals, they are length matched just approximately, no precise length matching. You still would like to see how much space you will need to do it properly. When I asked him to do this length matching, this was actually the initial layout, and I pointed out that when you are creating these waves, you would like to also keep maybe some space between them, okay? So this is how it looks when it is improved. The space between the waves is much bigger than what he initially created. Why we would like to draw the draft or preliminary layout this way? What do you think? Because even this is not the finished layout. If you do it this way, then this is not going to tell you how much space you will need. And when you are doing layout like this, you may get an impression that you have a lot of space, for example, here, and you may start doing layout also here in these spaces. And then when you try to improve this layout, when you try to route the memory interface properly, you will find out that this is not enough space to do it, and then you will find out that you have to reroute all these tracks what you have already routed here. You will need to reroute them somewhere else on different layers. It's going to be a lot of additional work. So even When you are creating a preliminary layout, when you are doing draft layout, you still would like to do it some kind of properly to get an idea how much space you will need for this specific interface. And if you would like to know more about the proper spacing between the tracks and between the waves, have a look at some of my other videos. This is what I have created some time ago. Okay, here you can find some recommendations, how much space you would like to maybe have between the waves. And here I'm speaking about a document which has some recommendations how much space you would like to keep between tracks. I'm not going to speak about this in this video what we are creating now, because this video then would be just much longer than it is necessary. If you would like to know more about this, then just watch the videos, okay? I will put the links under this video. If you would like to see how close these signals were a length match, I'm going to select this data bank tree, and you can see that the length of these signals is between 31 to 37 millimeters. So they are not precisely a length match, but you need to be sure that there is enough space to length match these signals later the way that they all can have same or very similar length. Now, the reason why maybe you don't want to precisely length match these signals now at this stage of the layout is because you can spend a lot of time doing this precise length matching, and there is very high chance that a little bit later you will need to move one of these signals and you will have to do the precise length matching again. And you can spend a lot of time doing this precise length matching now. Trust me, I learned this the hard way. I've been there, and I learned that doing the precise line matching, it is one of the latest things what you may want to do in your PCB layout. So it is one of the last thing what you do in your board, in your PCB layout. Precise length matching. Don't do it now. It will be wasted time. So just doing this approximate length matching in this draft layout, it is perfectly fine. And when we mentioned how important is the space between the tracks, I would like to show you something else. Have a look how close these differential pairs are routed. This is one differential pair, this is second differential pair, and the space between these differential pairs is even smaller than the space between plus and minus signals of the differential pair. This is not the way how to route differential pairs. Differential pairs are like really high speed signals usually. You really would like to keep a lot of space between differential pairs. Okay, very important. How much is lot of space? As much as you can, okay? At least same space as between the signals, but even that is not like enough. As much space as you can. Very important. I know this is still a draft, but even in the draft you still need to think if there will be space to improve this layout, if there will be space to move these differential pairs far away from each other. A little bit later, we will have a look at how layout of these differential pairs was improved. But there is one more important thing what I would like to point out on this layout. Notice how some of the signals of this LVDS1 interface, how they are routed. Some of the signals are routed on top layer and then they go to this through-hole vias and they are connected on the bottom to board-to-board connector. And some of the signals from the same interface are routed on the top layer, then they continue on layer 3, and after this they are connected on the bottom layer to the board-to-board connector. So some of the signals are routed only on top and bottom layer, and some of the signals are routed on top, layer 3 and bottom layer from the same interface. This is what I normally don't do. I normally try to route all the signals from the same interface. I try to route them the same way. So if I decide to use layer 3, then I will use it for all the signals in this interface. Especially if you need to do length matching, then it will be very useful for several reasons. One of the reasons is length in the vias will be exactly the same, and also keep in mind that signals are traveling different speed on a top and bottom layer and inside of the PCB. So if you route your signal only on top layer and bottom layer, then it may travel different time than the signal which will be using also layer 3. Okay? So ideally you would like to use same layers for the signals from the same group, especially if this group needs to be length matched. Why we would like to length match LVDS interface? Or how we would like to length match LVDS interface? There are some tolerances, but because we are designing the computer on module, we don't know how exactly the rest of the system is going to be connected to this LVDS interface. We don't know the baseboard where this module is going to be plugged in. We don't know anything about the cable which is going to be used. We don't know anything about the display what is going to be used and connected to this LVDS interface. So the best what we can do is length match all these LVDS signals to the exactly same length or very similar length. Okay, and for this the best way would be route all the signals the same way. And this is how it looks now. One of the ways how it was possible to improve this layout was to actually play with the pinout of this board-to-board connector. And because this is like completely new design, there is nothing about compatibility with previous revisions or boards or something. We could play with the pinout of this board-to-board connector, and this improved this LVDS layout a lot. So if you can change pinout of your connectors, then sometimes you may want to do it. Have a look how the layout was improved. So now this LVDS interface is routed on the top layer, then all the signals they continue on the layer 3 and then they finish on the bottom layer. And notice the length of these signals. We haven't done any length matching yet, and notice that the length is between 16 to 14 millimeters. They are almost exactly the same length. That's how changing the pinout on the connector improve the layout. Notice the space between these differential pairs, a lot of space. Okay, for the LVDS0, very similar. All the signals now they go on layer 10 and then they go on the bottom layer. Again, notice how far the differential pairs are now routed from each other, and there is enough space to do length matching if it is needed. Okay, so when you compare it with this, how it was done before, then everything is much better now. And when we are speaking about routing interfaces the same way, have a look at this NAND interface. I'm going to enable all the layers and I'm going to select this write signal. It is routed on top layer, layer 8, you can see it here, and then bottom layer. Okay, now data signal, top layer, layer 8, layer 5, layer 10, bottom layer. Read signal, top layer, layer 8, layer 5, bottom layer. You get the idea, okay? I know NAND interface is maybe not the most critical for a length matching, but same as for the LVDS signals. This is computer on module, and this interface is connected to board-to-board connector. We don't know how the baseboard is going to be done, how people are going to route the NAND interface on the baseboard. So the best what we can do is make the length of these signals on this interface same or very similar. And routing every signal on different layers or many signals on many different layers is not the best way how to achieve proper length matching of these signals. So this still needs to be improved. I don't have a better version of this NAND interface because we will be working on improving this. So I cannot really show you the improved NAND interface. But you have got the idea about the NAND interface. All the signals from the NAND interface, they should be all routed the same way. They should be all routed on same layers. When we were speaking about distance between two tracks or distance between differential pairs, you need to be aware there is also a rule which specifies the minimum distance between hole and a track, or between hole and a copper. When I click on this revision and when I zoom in here, notice how close this track is routed to this non-plated hole. Non-plated hole, it means there is no copper inside of this hole. And when I measure the distance between this hole and this track, you can see it is 0.1 millimeter. However, when I open these guidelines from this PCB manufacturer, and when I go on page number 7, you will see that they recommend the minimum hole to copper clearance for non-plated hole on the outer layers to be at least 0.2 millimeter. Okay, so this, what we have here, it's routed too close. This track is routed too close to this hole. Have a look how it was improved. Okay, now when I measure this distance, it is 0.211. So it's more than 0.2 millimeter. It's very important, be aware of the capabilities of the PCB manufacturer, what you are using. And when we are speaking about these spaces and distances, here is another tip. I'm going to open this revision of the board. I'm going to zoom in, and you will tell me what we would like to improve here. Do you know? These tracks are routed too close to the board edge. Why we don't want to route so close to this board edge, do you know? One of the reasons is that the environment close to this edge is changing. The environment where signals are traveling is changing. Also, when you route very close to holes, the environment around these holes is also a little bit different. So be very careful when the environment where signals are traveling, when this environment will change, it will influence the signal. Okay? So we don't want to route close to the edges because it may influence signals running through these tracks. Another more practical reason why you really don't want to route very close to these edges is because very often your PCB will be placed in a panel with multiple PCBs. And when assembly house will be assembling your boards, when they will be soldering components on your boards, then they will do it for the whole panel, and after they solder your PCB, they will need to remove this PCB from the panel. And there are different techniques how this is done, but during this process, when they will be removing your board from the panel, they can damage the tracks which are routed very close to the edge. Not always, but sometimes may happen, they can damage these tracks. They can even damage some components which are placed too close to the board edge. Okay, so be very careful. Don't forget to think about this. If you place components too close to the edge, if you route too close to the edge, this can be damaged when your board is removed from the panel. And when we have a look on this board, what I have here, I'm going to enable all the layers. You can see I created these whole lines, these green lines which are here. They are around the whole board. And this first green line, which is here, it is used to tell me how far I can go with the layout. So there should be nothing routed behind this green line which is here. So this should not be routed here. And this second green line which is here, this one, it is telling me how far I can place components. Okay, so you can see there should be no components placed further behind this green line. And the distance between the board edge and these lines is like this, just to give you an idea, okay? So this one is 1 millimeter and this one is 2 millimeters. So 1 millimeter minimum distance for layout from the edge of the board and 2 millimeters distance for the components from the board edge. But in your board, you may want to use like a little bit bigger numbers. Don't forget, this is a very small computer on module, so we cannot really add too much space here, but for bigger boards you may want to use bigger numbers. And that's everything for today's video. We were talking mostly about spaces, but I still have a list of interesting points what we could talk about, how we could improve this layout. And if you like this kind of format, leave comments. So I know I should continue creating this kind of videos. Last time you left a lot of comments and I was very happy to read all of them. I always read all the comments. Sometimes maybe I don't answer all the comments, but I read them. It was very interesting also for me. There were some comments pointing out some topics around the vias, so I learned a lot. I have got ideas to create maybe some other videos about these topics what are mentioned in the comments. So if you think that what I mentioned in the video is something what you do differently, leave it in the comment, explain why, so I can learn and also other people can learn from your comments. And if you just like this kind of format, you can just leave comment that you like it. Don't forget press like button and subscribe. Okay, I always keep saying subscribe because number of subscribers is helping me to create new interesting videos, to talk to different people, to talk to different companies, and it also motivates me to create new videos. Thank you very much for watching. Don't forget like, subscribe, and see you next time. Bye.